In any relation, the domain is the set of x values and the range is the set of y values. In this example, my domain is the set of x values, and my x coordinates all come first. Now typically we list our domain from smallest to largest, so I'll start with -2, and then 2, 4, and 8. So those are the elements of my domain, and my range those are my y values, so -1, 0, and 3. Notice that 3 is a y value twice, but we only have to list it once. In this example, we're going to evaluate a function. For example, I want to evaluate my function where x is equal to -1. That's what this f of -1 is. So I'll just substitute -1 in for my function here. So I have 3 times -1 squared plus 2 times -1 minus 4. So 3 times 1 minus 2 minus 4. 3 minus 2 minus 4. 3 minus 2 is 1 minus 4. So we end up with -3. F of -1 is -3. And then for my second problem here, we want to evaluate f at b plus 1. So I'm just going to substitute b plus 1 in for x. So 3 times b plus 1 squared plus 2 times b plus 1 minus 4. This b plus 1 quantity squared here has to be FOILed. You can go over to the side and do your scratch work if you want. B plus 1 times b plus 1. Some of you may already know what this is. We have b squared plus b plus b plus 1. So 3 times b squared plus 2b plus 1 plus, I'm going to distribute my 2 into the parentheses, 2b plus 2 minus 4, and then distribute the 3 into the parentheses, 3b squared plus 6b plus 3 plus 2b plus 2 minus 4. And then I really just have to combine my like terms. So I end up with 3b squared plus 8b plus 1. In trying to decide if a relation is a function, when we look at a set of ordered pairs like we have here in these two examples, we want to focus on the domain. And as long as your domain does not repeat 2, 4, 6, 8, you're good. Then you do have a function. But notice here, I have 2 listed as part of my domain twice, so that would make it not a function. And then when we're trying to decide if a relation is a function given a graph, we want to use what's called the vertical line test. For the vertical line test, basically if we can find any place where in our graph we're drawing a vertical line would cause the graph to touch the vertical, to intersect with the vertical line more than once, that makes it not a function. So here also a circle is not a function. But here, these are not perfectly vertical lines, but every vertical line that I cannot find a spot where my vertical line would cross more than once, so that is a function. And then this is kind of an interesting function. I included it just because it's kind of cool. Notice, definitely looks like it is a function, and it is a function. Notice that I have an open dot here and here in that one segment. That means that that point is not included. So when I try to draw a vertical line, which is off just a little bit, my vertical line actually still goes through that graph in only one spot because it's not included there. And then the same would be true here, except I didn't quite hit the mark. So this one is also a function. That's actually, this particular kind of function is called a piecewise function.